So this is a quick review, kind of part 2 from the worksheet. So for the worksheets, for each problem, after I had calculated my z and I established what area I needed, I then would go to the z-score calculator. So I'm going to go through one of the problems. So I'm first going to go through problem 1b. So problem 1b, I had calculated 86 minus 80.9, and I got 5.1, and then I divided it by the standard deviation, 7.7, and I got 0.66. So 0.66 was my z-score, and it asked what is the probability of scoring 86 or better. So I need to go up, right? So I'm actually going to switch over, and I'm going to pick the right side because I want this. And then my score that I got was 0.66. And so the probability of me scoring 86 or higher within the sample is 25.46%. And again, if I ask in probability, it goes with the percentages. So that's what I would be putting on my worksheet. I'd be putting in that 25.46%. So you're going to do the same things for 1 and C for problem 1. For problem 2, we are using a different formula where the denominator was that standard error, which was the standard deviation over the square root of n. So my standard deviation in this problem was 15. My n was 81. If I take 15 over the square root of 81 is 9, so 15 over 9 is 1.66666, or you might have done 1.67. And so I am going to go ahead and tackle 1b as well. So 1b is asking for 119. So I did 119 minus 100 over that 1.6666 or that 1.67. Depending on which one I did, I'll get slightly different decimals. And again, I adjusted for that in the Canvas assignment. And it's asking for the area above as well. So I'm still going to keep to this right. The problem, though, is that I, in working through this problem, made really large z-scores. And so we would be getting things over here, which would be super small. And it would actually be even smaller than that 4. Once you get to the 4, you're practically at 0%. So within this problem, it's saying it's something that's highly unlikely, which is very true because when you have samples of samples, you really are right around that mean area. And so again, if you're working through these problems for 2A, 2B, 2C, I will not be asking about the probability because they are much greater than they really would be in real life, which connects back to that central theorem idea. I will have a question in Canvas about this, though, where you can respond. They're nearly impossible and connect back to the central